Hi, uh, my name is John Furry from Section 1, and this is my member, Jansha, Naishiji, Junction, and University John Furry. So today I'll be presenting Chapter 1 and Chapter 2, which contains introduction and literature review. So the Chapter 1 is introduction, so background study. So stroke have been affect over 14 million people worldwide. So and it causes highest death among people aged 15 and 59. So there are three types of stroke, which is ischemic stroke, hemorrhagic stroke, transition ischemic attack, which is mini stroke. So basically, stroke is something happen when something happen to the blood flow to your central nervous system. We call it as cerebral vascular accident, which is CVA. So when stroke occurs, often causes brain uh, occurs in the brain and causes paralysis and memory deficit, speech and visual issue, emotional difficulties. So in 1997, annually have been conducted a research which produced a result which one of three caretakers will have spinal cord injury due to the patient. So we need to design something that can help caretakers to take care of the stroke patient. So the first one is the device must be portable. The second one is the device can be stroke patient, can be transferred stroke patient from bed to the tray. And doing the reverse activities. The third one is related to gender equality, which is can use for all gender. The next one is the device is able to store the activities based on the patient or the device and a cloud database. The device can check heart rate, and the next one is the device need to be related to IoT. The patient should be half paralyzed and much more. Then this is our Gantt chart, and this is literature review, which is basically we go into the market and search for review for the available design. So the first one is Sarah Safety Standing Aid, which is not affordable, only bed to wheelchair. The second one is electric use hydraulic and 5,250 from usage is bed to wheelchair. The third one is more lift to seat to stand patient lift, which is to stand and sit vice versa, which is 3,500, 3,500. And the fourth one is the car, exclusively to the car, which is 21,000. So basically, these are our review pattern, which we will use to innovate and maybe to upgrade the design and make it affordable for the people in need to buy it. So that's all from me. Thank you.
Good day, doctor and friends. Today I'm going to present the PDS for our group project. So in our PDS, we consider weight, dimension, material, ergonomics, features, cost, performance, safety, service life, and lastly, time scale in our PDS. So the PDS is important because it adds a starting point for every designing process. After that, we need to construct conceptual designs. Before constructing it, we need to list down the functional of the device. There are a total of 8 functions in our functional design tables. Firstly, which are move, adjustable, lift patient, store activity history, safety, sit, support, and handle. Besides, we also construct functional block diagram. In block diagram, there are several functions. Firstly, lift the patient from bed. Next, move the patient to device, secure the patient in safety position using a safety belt, and we adjust the patient in correct and comfortable posture. Then we move the patient to another location, and throughout the process, we're able to store the activity history of the patient using the IoT device such as Arduino and Wi-Fi. After that, we construct a morphological chart, which is a visual representation of necessary product functionality. Each members required to contribute one solution for each function. This is the morphological chart for our team. Based on morphological chart, we need to generate 2 design ideas based on it. Hence, there are a total of 8 conceptual designs. These are the conceptual design construct by us. After all the conceptual design have been done, we need to do the evaluation and select the best design. Before starting the evaluation, we need to set the criteria for the selection. And these are the criteria, which are weight, size, complexity, ergonomics, ease of use, manufacturing cost, ease of handling, safety, service life, and lastly, minimal maintenance needed. And each function, each criteria have the weightage is set it respectively. In the first selection, start with screening matrix. Before starting a screening matrix, we need to select a datum. The datum is an existing product used by us to compare the design. The mark will be given based on the comparison with the datum. This is the datum we choose, which is Sarah's Daily Patient Transfer Act. This is the screening matrix of our project. Based on a screening matrix, it shows that the concept 2, 3, 4, and 6 will proceed to the next stage, which is the selection of the final concept based on the scoring matrix. Next, for scoring matrix, we share the same selection criteria as the screening matrix. And after the screening matrix, we found that the concept 4 has the highest marks among the other 3 designs. Therefore, the concept 4 is selected as the best design. Therefore, we need to do some reflection on it to see which part we need to improve it. And after a discussion, we can conclude that the design meets the aims and needs of this project.
I'm Jingsun and I will be explaining about the details of design related to manufacturing, assembly, costing and failure analysis of our design. So this is the final concept sketching. Besides the standard parts used, we divide the assembly into 3 parts: the bottom, middle and top, which is sub-assembly 1, 2 and 3. In the bottom part, to move and support the system, the middle part is to support the top part, which is used to move the patient up and down from the bed. This is the bill of materials of our use for the assembly of our product. Most of the materials are made of aluminium 6061 and the standard parts are mostly made of stainless steel. The other special parts such as caster wheel are made of rubber, and the other special part are safety belt and sling bag, which is made of polyester. So we have also done the functionality assessment for the essential parts are determined based on the if they have exclusive movement, or it can be made by specific materials, or the part must be separated during assembly. If any one of these are true, there will be an essential part. So as a summary, we have 64% of our parts which is essential as our design efficiency. Next, we have done our failure mode and effect analysis. For most parts, the failure are due to fatigue, so we plan to use a stronger material, which is aluminium 6061. Other parts which are standard are mostly prone to wear and tear, so we plan to provide extra spare parts for such standard parts. After we have obtained all the materials, we calculated it by using the price we found on internet. The overall price is for the whole item is 3,850 ringgit, with 250 ringgit being the manufacturing cost. This is the calculation and the number of items we use as standard items. Next, we do the engineering analysis by using SolidWorks to determine if our system is safe enough to be used. We assume a person with 800 Newton is using our item. For the base, it can be seen that the largest stress is lower than the use strength, which shows that it is safe for use. The safety factor is more than 20, which shows that even if a person with 800 Newton sitting on it, the person will still be safe. Next, with the support 1, the same thing, where our stress on the material is lower than the use strength, and the safety factor is more than 20. For support 2, we also have the highest stress lower than the use strength, and higher stress lower than use strength, and the factor of safety is also more than 10, which is 12. The same goes to support 3, our hook, our sling, caster wheel, and other components. For our engineering drawing, we will show the engineering drawing for each component and the exploded drawing for the assembly. This is the sketch exploded drawing for the assembly, and this is the assembly generated by SolidWorks. This is the exploded view of the assembly where all the parts and accessories such as standard items are included. This is the front view of our assembly, this is the top view, and this is the side view. This is our bottom assembly, which consists of the caster wheel and U-shaped base. This is the separated U-shaped base, and this is the caster wheel with brake. This is our support 1, this is our control box. This is the caregiver handle, which is attached to support 1. After we finish our drawing and Lucas costing, we proceed to the sustainability analysis, which is also a function by SolidWorks. We set our manufacturing place and use in Asia. We also decided that our product should be used for 10 years. Because we are not considering the electric cost, the energy amount is as not included. These are the generated pie charts by SolidWorks. The most energy is used in the bottom system because it's the most heaviest and is the most rigid support of our product. All of these factors are accounted in the SolidWorks sustainability analysis. Next, my teammate Bear will present the functionality assessment for this product.
Hey everyone, my name is Bear Xiang. So my good members are Nai Shije, Wei Jingshun, and Don Bukhari. So for this SEMM4533 system design project, our group are needed to design a portable stock patient transfer device. So why we want to design this? So this is to assist the caregiver in doing the transfer process of the stock patient from one place to another place, and then it can reduce the human error and the injury risk either to the caregiver or the patient. Okay, next. So this table shows the list of words or the function of our design. So for our design, we focus on the function move function. So it can transfer the patient from one place to other place. Next, adjustable function. So the height of the seat should be adjustable so that it's available from the different height of the patient. So lift patient function. So it can help patient to get out from the patient seat in cast on bed easily without by themselves. So it is by using the device to lift them out without them need to use force to get out, something like that. Okay, so for the store activity history function, so our device also can able to check the heart rate of the patient. Okay, next, safety function. So our device have a safety belt. Besides that, we also having the caster wheel also having the brake at the lock to lock down so that to prevent the device to move during the transferring process. And then seat function. So on our seat, we also provide the cushion material for the seat so that user can sit on it very comfortably. So seven is the support. Excuse me. Is to provide the excuse me is to provide the pivot point for the patients when they want to move. Okay. So the last one is the handle. It's for the caregiver used to transfer the patient. Besides that, patient also can hold the handle during the transferring process. Okay, next I will show the full assembly of our design, and then I will demonstrate the function. Okay, as you can see, this is our design. So the bottom one is the U-shaped base, is the for the main support purpose, and then the under the U-shaped base is the caster wheel with the brake. Is the caster wheel with the brake. Okay, caster wheel with the brake, and then have the control box inside, have the motor to control the hydraulic cylinder to work, and then this is the support 1, and then support 2, this is a support function, and then this is the handle for caregiver, okay, to push one, and then we have the hydraulic cylinder to lift the patient one. Okay, besides there also the support tree, and then okay, so this one is the patient handle, and then this one is a sling bag. Okay, so I will explain the lifting function for the adjustable and the lifting functions first. So as you okay, this is the condition. So we want to transfer the patient from the bed, and then okay, so we need to give the patient to sit on the sling bed first lah. Okay, so this is the situation when the patient sit on the sling bed first, and then okay, so after the patient sleep on the sling bed, okay, so okay, and then okay, we can use the remote control to control the motor to operate the hydraulic cylinder, to operate the hydraulic cylinder to lift up the support tree. Okay, so when we operate the hydraulic cylinder, okay, it will lift the patient, okay, from the bed, so it can do the transferring process, and then after it lift up the patient, okay, so the customer can move, we can use the handle. Okay, so the caregiver can use the handle to push the device. Okay, so okay, after lift up the patient from the bed, okay, the caregiver will use the handle to pull the device, okay, do the transferring process. So the customer can help to do the transferring process, and then we also have support 3, okay, support 2, okay, support 2. Okay, wait, and then we can, when we want to transfer the patient back to the bed, okay, so you just use the remote control to control the motor, and then make it. Okay. Okay, so okay, you just control the support key to downwards. Okay, okay, something like that. Okay, so this is the adjustable. Okay, you can up and down. It is adjustable. The support tool is adjustable according to different height of the patient. So maybe the patient is too high, it can use the support tool to adjust the height. Okay, and then okay, just now I also show the lifting patient from the back, and then we also show the moving function, and then okay, inside our sling bag, okay, we have cushion material, so the patient can sit very comfortably, and then for the customer will have the brake, during the brake to lock down during the transferring process, you can fix it, and then we also have the safety belt. Okay, okay, safety belt can be ensure the safety of the patient during the transferring process. Okay, so for the handle, the patient during the transferring process, the patient can hold the handle. Okay, can hold the handle. Okay, inside the handle, it has the heart rate sensor. It can detect the heart rate of the patient, and then when the patient hold it, and then when it can save the data to the cloud base, and then we can use the phone. Okay, we can use the phone to log in the cloud base, and then we check the data of the heart rate of the patient. Okay, okay, that's all of our demonstration of the function of our design. Thank you.